This is one of my favorite demos. You may have encountered one of these in a preschool setting as a so-called wave bottle. Well, to make one of these is a pretty simple exercise. You take some corn oil, which often has some yellow pigments in the non-polar oil medium, and you put some food coloring. In this case, I use some blue food coloring in a water medium here, in a polar aqueous medium. And what we see is the less dense non-polar phase here floats above the more dense polar phase. So non-polar above the polar in this case. And they don't really mix very well at all. You can do color mixing here, maybe with the kids, and you can show kids that yellow and blue together make green, but you can see that it separates out pretty readily. So there's all sorts of interesting things you can unpack in this, density and polarities of solvents and how well things mix together, and like dissolves like, as they say. But I wanted to also add in this. This is a similar bottle, only with the oil and the water with the blue food coloring. But what we've done is we've added a little bit of soap to this, and the soap is a little bit polar and a little bit non-polar, so it's attracted to both the oil and the water. And what this will do is, if I shake these up, it'll help the oil and the water mix together more easily. It'll make it harder for them to separate out. So what I'm going to do is I'm going to shake these up here. Okay, and I'm shaking them up. Okay, and I'm going to let this sit for a little while. And I won't let this sit for hours because it'll take too long for it to separate out. But what you should be able to observe is that without the soap, or surfactants, the surface active agents as they're called, you can see that the oil and the water are separating back out from each other. With this soapy material, this material with this intermediate polarity or intermediate attraction to both water and oil, you can see that the oil and the water stay mixed up for a lot longer. And this is one of the reasons that soap is good for killing germs, for example, like the COVID-19 virus, because many germs, including the COVID-19 virus, have sort of a soapy outer layer, or sort of an oily outer layer, and the soap helps destroy that layer. This is one of the ways in which alcohol can also be used to destroy germs like the COVID-19 virus, because many alcohols are intermediate in polarity. They're not quite as polar as water, but they're not quite as non-polar as oil. They're intermediate, and then again, they can help they can help break up the oil outer layer of the germs. So there's a lot of information you can get out of this very simple demo.